Right, so we'll work through the selected questions from the paper 1, May 2019. This is the paper that we went through in class today, Monday the 15th of May. So we're going to do questions 1 to 9, and then 13, 14 and 19a. Question 1. Express 315 as a product of its prime factors in index form. So we repeatedly divide that number by prime numbers, and I can see that 2 won't go into it because it's odd, but 3 will go into that, 1, 0, and then won't go into 1, so it goes into 15 5 times. So 105. That 5 goes into, 5 doesn't go into 1, but it goes into 10 twice and into 5 once. 3 goes into 21 7 times, and then 7 goes into 7 once. You you continually divide by prime numbers until you end up with 1 at the bottom. So 315 is going to be 3 times 5 times 3 times 7, which are the divisors there. To get full marks, you need to write it in index form, which is going to be 3 squared times 5 times 7. You could put it as 5 to the power of 1 and 7 to the power of 1. That's correct, but if you don't, that's not the end of the world either. So you've got a method for repeatedly dividing by prime numbers, prime factors, an answer mark if you've got the 3 times 5 times 3 times 7 in any order, and then the third mark is for turning that into index form. For the second part, what is the highest common factor of 315 and 42? By far the most straightforward way of doing this is to use the Venn diagram, because you've already broken 315 down into its prime factors. So if we do the same with 42, 2 will go into that 21 times, 2 will go into that, no it won't, sorry, 3 will go into that 7 times, 7 goes into that once. So 42 is 2 times 3 times 7. So then if you do it down here in the blank bit, a Venn diagram, 315, 42, and then we look for the overlap. What factors are in both? So 2 isn't in both. There's a 3 in that one and a 3 in that one, so that can go in. And there's a 7 in that one and a 7 in that one, so that will go in. There's nothing else that's common, so in the 315 we've got a 3 and a 5 left, and in 42 we've got 2 left. If the question wanted you to give the LCM would be the product of all of the numbers in the list, so 2 times 7 times 3 times 5 times 3. We don't want the LCM, we just want the highest common factor. Highest common factor is what you've got in the overlap. So the HCF will be 3 times 7, which is 21. Okay, now that takes longer to explain than do. Okay, just taking the second number, we've already got the first list, take the second list, overlap, fill in the intersection with what's in both, complete the rest. If you want the LCM, it's the product of all of those. If it's the HCF, it's the intersection. So method mark for finding the highest common factor, answer mark for getting it right. Question 2, we're seeing these pretty much in every non-calculator paper, so it's really important that you can nail this. So complete the table below. Draw the graph of y equals 3x squared minus 25 for values of x between minus 3 and 4. Use the graph paper below. So the only thing that makes this one different is, as you can see, doesn't have values on the vertical axis. So you're looking at your y coordinates, and you can see it's got to go up as far as 23 at least, and down beyond 25. So the smart money would be on 10, 20, 30, because then I got space for my 23, minus 10, minus 20, minus 30. And that's a nice easy scale as well, because it means that each little square is 1 unit. Plot the ones we know. So I've got minus 3, 2. Don't know minus 2. Minus 1, 22. 0, minus 25. 1, minus 22. 2, minus 13. 3, 2, 4, 23. So I'm looking at expecting a U-shaped graph, looking at those plots. So for minus 2, I'm looking for something probably around about minus 5, between minus 5 and minus 10 anyway. So if I get an answer somewhere outside there that's going to make the curve jump, I know I've done my maths wrong when I substitute minus 2 into that. So when I'm putting x equals minus 2, it's going to be 3x squared, so that will be 3 bracket minus 2 squared, take away 25. Now minus 2 squared means minus 2 times minus 2. 2 times 2 is 4. Minus times a minus is a plus. So that's going to be 3 times 4. Take away 25. 3 times 4 is 12. Take away 25 is minus 13. So that will be minus 13, which will be 1, 2, 3 there, which fits quite nicely. I was anticipating something between minus 5 and minus 10. It's a little bit lower, but that looks right. Certainly isn't going to create a lump. And then the last thing we do is we join the points with a smooth curve. Okay, so just missed that one there. So I'd have rubbed that out and done it again. So there's 4 marks for that. There's 1 mark for the axis. There's 1 mark for calculating the negative 13. 1 mark for plotting the points. And 1 mark for joining them with a smooth curve. Question 3. In this question, you will be assessed on the quality of your organisation, communication and accuracy. So you need to do a little bit of explaining here what you're doing. A regular octagon with centre O is shown below. Calculate the exact size of angle OAB. Okay, so there's the angle that we have to work out. You may choose to draw additional lines on the diagram to help you. You must show all your workings. So the key information you've got here are these 2 words. Regular means all the sides are the same length. Okay, and all the angles will be the same because of that too. And the octagon means it's got 8 sides. So 8 equal because it's regular sides. Now, how that is going to help you is it actually means that, and they're giving you a clue because they're telling you you may like to draw some additional lines. Okay, what we're going to have is we're going to divide this shape up into 8 triangles, and each of those triangles is going to have the same angle around that central point there. So around O, we will have 8 equal angles around O, and that means that those are going to all add up to 360 degrees because they're angles around a point. Adding to 360 degrees. Okay, so that line there is basically unlocking this problem. So each angle is going to be 360 degrees divided by 8. Remember, this is a non-calculated paper, so your non-calculated division is important. 8 into 3 doesn't go, so we go 8 into 36. 8 goes into 36 4 times. 4 8s are 32, so there'll be a remainder of 4. That means that that will be 8 into 40, which is 5 times. So the angle at the top of the triangle is 45 degrees. Now, because this shape is regular, it means that distance OA and OB and OC and OD all have to be the same distance as well, which means that triangle OAB will be isosceles. That and that are equal. They're not equal to the side AB, so all the sides on the outside are equal, and all of these spokes, I suppose you could call them, from the center to the outside, to each vertex, each turning point on the outside, are equal. So because that's isosceles, angle A and angle B there, so angle OAB and OBA are the same. So to work out those, we're going to do 180 take away 45. (135 degrees). So those two have to add up to 135. So I've got to do 135 divided by 2. 2 into 1 doesn't go. 2 into 13 goes 6 times. Remainder 1. 2 into 15 goes 7 times. And then we got to put a decimal point in there. Add a 0. Remainder 1. 2 into 10 goes 5. So angle OAB equals 67.5 degrees. So there's 4 marks for that. There's 1 mark for working out the angle at the center. So we'll have 1 mark for the 45 degrees. We'll have 1 mark for recognizing we've got an isosceles triangle. 1 mark for working out the 135 degrees and then dividing by 2 to get your final answer. And then your OCW, it'll be brilliant if you do use sort of a line like that and a line like that. But so long as you're identifying that's isosceles, so these base angles are the same, how you articulate it is fine. But that will get you the 2 marks. So the +2 for the OCW. Also, when you're working with angles, be consistent with the degrees. Question 5, constructions. Now, it's been depressing me a little bit how rubbish you are at having remembered constructions. So on the Google Classroom, I will link the work that we did to that as well. So point P lies on the perpendicular bisector of the line AB. So we need to cut that exactly in half. Okay, and there's one construction and only one construction that will do that. And then B to A, to wherever this point P is on the line, is an angle of 30 degrees. Now, what you should be thinking straight away is, oh, I don't know a construction for 30, but I do for 60. And 30 is half of 60. So I know how to construct 60, and I know, if you've practiced, how to bisect an angle. So we look at that. But first of all, we'll do the perpendicular bisector. So to do the perpendicular bisector, you have to put the compass point at one end of the line you're cutting in half, and you have to open it so that it's over halfway. You don't have to measure it, but it has to be over halfway, otherwise you're not going to get intersecting curves here. So from point A, I've drawn that. I don't change my angles, my compass size now, and I move the compass point to B, and I draw another curve like that. Point P is going to lie somewhere on that line. Okay, so the line now I'm joining up where the two curves intersect either side of the line. Point P is somewhere on there. You've got one mark for constructing the perpendicular bisector, even if you go no further. We've then got to draw our 60-degree angle, and B to A to P, this is where our angle is going to be. So a 60 is the most straightforward one to construct. You put your compass point at A, because that's where we want our angle to come from, and we open up our compass. It doesn't have to be any particular size. So don't make it massive, don't make it tiny. And draw an arc. Now, you've got to have something to intersect, and 60 degrees is going to be up there somewhere. So even if you can't remember this, there's only really one place you could put your compass point now, which is there. So you put your compass point there, and you draw the arc again. And this, between A and where that crosses, is 60 degrees. Okay? So you're going to have one mark for drawing a 60 degree. But we don't want a 60, we want to cut that in half. So you need to remember from practicing this how to bisect an angle. So to bisect an angle, you put the compass point at the center of the angle you want to cut in half, and you mark across each of the angle sides. We happen to have that already. What you then do is you have to move the compass point to where it crosses one side and arc into the center. Then without changing it, move it to the other side and arc into the center. That will give you that angle cut in half. Now we know that that is 60, so when we cut it in half, that is going to be 30. So where is line P? Point P is going to be where the two pink lines intersect. And it says there, show one of the possible positions of P. There is a second possible position, which is if you'd have drawn your 60-degree angle below AB rather than above AB. And then point P would have been down there. So you've got one mark for the bisection and one mark for correctly finding where P is. Now the examiner in a question like that is looking for these curves, these construction points. So it's important that you practice those. We know a construction is coming up. Question 5. Estimate the value of this. So when you're estimating the value, what you do is you round your answer to one significant figure, or in most cases the nearest whole number. So, one significant figure. So that's going to be 30. That would be 2 cubed, and underneath will be 0.5. 2 cubed, 2 times 2 times 2 equals 8. So that will be 30 times 8 divided by 0.5. So 30 times 8, 3 8s are 24, so that's going to be 240 divided by 0.5. At this point you need to be careful, because the most common and wrong answer here would be 120. 120 is a half of 240, or a half times 240, not a half divided by 240. If you're not sure, think about what you would get if I was dividing 1 into halves. There'd be 2 of them. Yeah, a whole would split into 2 halves. So 1 divided by a half actually is 2. It doubles it. So my answer is going to end up as twice as much. It's going to be 480, because every one of those is going to be divided into 2. The way to do it mathematically is to say, right, I want to get rid of that decimal underneath, and I can get rid of that by multiplying by 10. If I multiply the bottom by 10, I have to multiply the top by 10 as well, otherwise I change the sum. Now I'm just dividing by 10 divided by 10, multiplying by 10 over 10, which is 1. So I get 2400 over 5, because a half times 10 is 5. So 2400 divided by 5, back to the bus stop. 5 into 2 doesn't go. 5 into 24 goes 4 times, remainder 4. 5 into 40 goes 8 times. 5 into 0 goes 0. So 480 is the estimate. Okay, so be very careful. As I said, most common mistake would be 120. So method mark for rounding your answers to one significant figure. Answer mark for getting 240 over a half. Answer mark for correctly then getting 480. Question 6. So this is relative frequency, which sounds new. I haven't gone through this with you, and I don't think it's coming up, but I'll take you through it anyway. It's basically just fractions work. On the first day, a random sample of 2,000 visitors at the show were asked, do you live in Anglesey? 640 of them answered yes. What was the relative frequency of those who answered yes? So how many answered yes out of what total? 640 out of 2,000. Give your answer as a decimal. So we can make this simpler. We can divide by 10 because we got a 0 top and bottom. So that's going to be 64 out of 200. To turn it into a decimal, just have it out of 100. So out of 100, I can divide both of those by 2, and I get 32 out of 100, which is 0.32. So that's 0.32. On the second day, a random sample of 3,000 visitors at the show were asked the same question. The relative frequency of those who answered yes on this day was 0.42. Calculate the relative frequency of those who said they lived in Anglesey when the samples for both days were combined. Give your answer as a decimal. So this time I've got to work backwards to find out how many of the 3,000 said yes on the second day. So I've got to work out what 0.42 lots of 3,000 is. Well, 0.42 is 42 out of 100 times 3,000. I can divide by 10 twice. So I've got 42 times 30. So if I do 42 times 3, then I'm going to get 126, and I've got an extra 0 there. So 1260, that's how many answered yes on Tuesday. On the second day, sorry. So over the 2 days combined, the number of answered yes is going to be 640 plus 1260 out of 2,000 on the first day plus 3,000 on the second day. So that's going to be out of 5,000. I want our answer as a decimal again. So I will work out what 640 plus 1260 is. 6 and 4 is 10. 6, 7, 8, 9, 1900. So I can cross off 2 of those. So that's going to be 19 out of 50, which if I want to make it out of 100 to make the decimal easier, I can times top and bottom by 2, and that will give me 38 out of 100, which is 0.38. Which of the following is most likely to give you the best estimate? It's going to be my answer to part B, because with any relative frequency, the more more repeated trials there are, or the more repeated samples there are, the more reliable your outcome. So it's my answer to part B, because the sample size is largest. So rather than being out of 2,000 or 3,000, it's out of 5,000. Okay, so B1 for the first, B1 for the last. You're going to have an M1, A1, a method for working out how many answered yes on day 2, and then getting the right value, and then a method and an answer for working out combining over the 2 days. Question 7. So we're comfortable into grade B land. A mass is written as 430 kilograms, correct to the nearest 10 kilograms. So if it's going to be correct to the nearest 10 kilograms, you're going to be counting up 430, the next one would be 440, the one down from that would be 420. So if you're clicking between 420 and 430 for the least possible value, you're going to be at the halfway point, which will be 425. Time period is written as 22 seconds, correct to the nearest second. So if you correct to the nearest second, 22 will be what you're rounding. If you're rounding up, you'd end up at 23. The next one down would be 21. What's going to be, we want the least, so what's going to be the trigger point between 21 and 22? It'll be 21.5. A population is written as 85 people, correct to the nearest 5. So if we go and correct to the nearest 5, up would be 90, down would be 80. Halfway, and we want the least, halfway would be 82.5. Well, we can't have 0.5 of a person, so because of the context of this, the nearest will be 83, because 82 would round down. Calculate 3.4 times 10 to the minus 5 times 700, give your answer in standard form. Okay, when you're multiplying or dividing, I always suggest you work in standard form. So we've got 3.4 times 10 to the minus 5, and then we'll turn 700 into standard form. So if you can't remember, we've got our decimal point, then we've got 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3, and so on, going that way. And if we're in small land, we're going 0, negative 1, negative 2, and so on that way. So 700 is that which is going to be 7 times 10 to the power of 2. When we multiply or divide, we deal with the number parts separately to the power parts. When we multiply base 10, they're both the same, I add their powers. Let's just work out what 3.4 times 7 is. 7 4s are 28. 7 3s are 21, 22, 23. So that's going to be 23.8. 23.8 times 10 to the minus 3. Now that isn't in standard form because this part isn't isn't the decimal number between 1 and 10. 23.8, if I write that on my grid, is going to be 2.38 times 10 to the 1 times 10 to the minus 3. So this is now between 1 and 10, and I add these powers again because I'm multiplying. So 1 take away 3 is minus 2. Now that seems a lot of work for 2 marks, but it's work you can do and you're not going to run out of time. So there'll be 1 mark if you get 23.8 times 10 to the minus 3. 1 mark for getting the final answer in standard form. Question 8. Leah is visiting Cardiff. The probability that she will go on a tour bus is 0.3. The probability of Leah seeing a show at the Millennium Centre is independent of her going on the tour bus. It makes no difference whether she's gone on the bus or not. The probability that she goes on a tour bus and sees a show in the Millennium Centre is 0.24. Complete the following tree diagram. Now, you need to be careful here. There's a trap that is easy to fall into. First of all, the first branch is straightforward. Either going or does not go, they've got to add up to 1, so that's 0.7. But this is not going to be 0.24 here. And if you didn't read that, okay, the probability that she goes on a tour bus and sees a show is 0.24. So 0.3 times the probability that she sees a show equals 0.24. They're not telling you in the question what that value is, which in some of the probability trees they have done. However, we have done ones like this as well. So we've got to work out what are we going to multiply 0.3 by to get 0.24. Well, just rattling through your 3 times table will hopefully get you to 0.8, or the fact that 3 eighths are 24. So this is 0.8, which means that's got to be 0.2, which is then repeated in the run beneath. So that's why that one is worth 4 marks, whereas it's normally worth 2 or 3. So you've got 1 mark for the 0.7, you've got 2 marks for the 0.8, and then you've got 1 mark for finishing off. Calculate the probability that Leah does not go on a tour bus and does not see a show. So does not go on a tour bus and does not see a show means you're moving continuously in that direction. That's the only path you're going to take to get there. So there's no oaring involved. So you're going to multiply 0.7 times 0.2 to get 0.14. Method mark for writing 0.7 times 0.2. Answer mark for correctly multiplying it together. Question 9. Arthur, Sian and Kezia are all given some £1 coins. Arthur receives n of them. Sian is given 5 times as much as Arthur, so that's going to be 5 times n. And Kezia receives 3 times as much as Arthur, 3n, plus an extra 7. And it's not an extra 7n because it's not plus an extra 7 times as much as Arthur, it's just an extra 7. Write down an inequality in terms of n that illustrates the fact that Sian, 5n, received less than Kezia, 3n plus 7. So that amount is less than 3n plus 7. It points to the smaller amount. So the arrow, if you think of that as an arrowhead, always points to the smaller amount. What's the greatest amount of money that Arthur could have been given? So we need to work out from this the value of n. And we do that using just the rules of equations. I want to get the n's on its own, so I'm going to take 3n off there, which means I have to take 3n off there as well. 5n take away 3n is 2n, is going to be less than 7. To get the n on its own, I have to do the opposite of timesing by 2, which is dividing by 2, which means I've got to divide that by 2. That'll leave me n is less than 3.5. So n is less than 3.5. So n must be less than £3.50, but he's been given pound coins. So Arthur has less than £3.50. So what's the greatest amount Arthur could have been given? So in pound coins, he has at most £3. So here we've got 1 mark for the 5n, 3n plus 7, 1 mark for the inequality pointing in the right direction. Here we've got 1 mark for n is less than 3.5 and 1 mark for interpreting in the question, the context of the question. That means he's got at most £3 because he's only got £1 coins. So that's question 9. Question 10 we can't do. Question 11 we can't do. 12 we can't do. 13 we can. So express 0.248 recurring as a fraction. So we write x as 0.24 and the recurring part of this is the 8. That's just going to keep going. So we want to then multiply by tens, hundreds, thousands so that we've got just the repeating part after the decimal. So the smallest value we can do there is 24.888, which would be timesing by 100. So I've got 100x is 24.888888. If I subtract those two, it's not going to get rid of the repeating decimal, the values after the decimal, because the 2, 4 and the 8, 8 won't cancel. So I have to times it as well by another power of 10 by 1,000, which will give me 1,000x, and on this side then I'm going to have 248.88888. So now when I subtract, I'm going to have 1,000x take away 100x is 900x, and on this side I'm going to have 248 take away 24, which would be 224, and then the 0.88888 will all cancel. To get the x in its own, I divide by 900, giving me 224 over 900. Method mark for getting everything lined up and subtracting. Answer mark for the final fraction. Okay, so then we're back to these, which again have come up pretty much on every non-calculator paper we've done. The minus tells us we've got reciprocal. That means you turn it upside down as a fraction. So if it was 27, it would become 1 over 27. If it's 1 over 27, it becomes 27. The bottom of the fraction tells us it's a root. The fact it's 3 means it's the cube root. And the value on top tells me that I've got a square. It's the power. So I'm squaring in this one. So the minus means my 27 becomes 27 over 1, turns it upside down. I've got the cube root and I'm squaring. So the cube root of 27 is what am I multiplying by itself 3 times, and it will give me a value of 27. If you're not sure, just figure it out. So 1 times 1 times 1 is 1. That means 1 cubed is 1 times 1 times 1. The cube root of 1 is 1. 2 cubed is 2 times 2 times 2. 2 2s are 4, 4 2s are 8. 2 cubed is 8. The cubed root of 8 is 2. 3. 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. 3 cubed is 27. The cube root of 27 is 3. So that is going to be 3 squared. Cube root of 1 is 1, so it's just over 1. We don't need to worry about that. Let's put it in just in case you're confused. 3 squared is 9. 1 squared is 1. 9 over 1 is 9. So that all works out to be 9. So there'll be 1 mark for figuring out the various bits of that, turning it upside down, and 1 mark for then getting the final answer of 9, not 1 over 9. 14 we can't do, 15 we can. So this is surds, links in with the work we did on indices. Square root of 45, you take the number that you've got, and if we're simplifying it, you're trying to find a factor pair of 45 that includes a square number. So I can write 45 as 9 fives. With the rules of surds, I can take that and write it like that, and I can take that and write it like this. Square root of 9 is 3. 3 times root 5 is 3 root 5, which is that one. So you could take a surd like that, split it into a factor pair, break out the roots, and then the reason we're doing that is we're picking a square number which I can write as a whole number. When they ask you to evaluate a bracket squared, the first thing you do is write it as you're multiplying it by itself. So I'm doing 2 root 7 take away root 3 multiplied by 2 root 7 take away root 3. We're then going to multiply that out using FOIL. Now because you won't be super duper confident with your roots, we'll write this out without evaluating any part of it. So the first is going to be that times that, which will be 2 root 7 times 2 root 7. Then the outside will be 2 root 7 times root 3, positive, negative, signs are different, answers negative. Then on the inside, we're going to have root 3 times 2 root 7, minus times a plus again. And then finally, we're going to have root 3 times root 3, both are negative, signs are the same, answers positive. So we've correctly expanded our bracket, but we haven't yet gone wrong because we haven't done any simplifying of the surds. So there will be 1 mark for correctly getting rid of the brackets. Now let's do some simplifying. So when I'm multiplying this, I got 2 times 2 is 4. When you're multiplying a root by itself, so root 7 times root 7, you just get the value inside the root. So that's going to be 4 times 7. With this one, I've got root 7 times root 3. So we're going to do the opposite of this now. Because they're not the same value, the square root of 9 times 5 is the square root of 45. So the square root of 7 times the square root of 3 is going to be the square root of 21. Same here, that's going to be the same. It's 2 times the square root of 21. 2 times root 3 times root 7. And then the last bit is going to be the square root times itself, it's just 3. So I got 28, 4 7 28 plus 3 is 31. And then I've got minus 2 root 21, take away another 2 root 21. That's the same as saying minus 2x, take away 2x. It would be minus 4x, but in this case it will be minus 4 root 21. So then the second mark is for correctly dealing with all those horrible square roots. So that wasn't a very nice one, but it's something you can do. We've worked with those now all this year. And then the final one for us to do is 19a, which is a kiss and smile. It's a simplifying a fraction, and this is actually easier than lots of the ones that we've done before. So here we've got, remember, the kiss is that times that over that times that. So we've got 1 bracket x minus 1 bracket x minus a on top, and underneath we got x minus a times x. So we've got on top x, minus 1 times x is x, plus 1 times a is a, minus times a minus is a plus, all over x bracket x minus a. It's just, that's the way we would tend to write it. You could leave it like that, there's nothing wrong with it at all. X take away x is nothing, so we're left with x on top and x bracket x minus a underneath. Job done. So you've got a method for your kiss and smile, bringing it all together, and the answer for finally simplifying what you've got on top. And that's it. So that was the paper from May 2019, pre-COVID, 80 marks. If you could follow everything I did on that, you get 52, which is only 1 mark off an A star. So even with that dodgy octagon question and the relative frequency question, you comfortably got enough marks there to get a grade A.